So the equation we're given is x minus 3 squared plus y squared equals 1. And we're told even that this is the graph of or the equation for a circle of radius 1 centered at the point 3, 0 on the x-axis. So the first thing we're asked to do is to implicitly differentiate this. So if we take the derivative of the right-hand side, that's a constant, that's always 0. In the case over here, x minus 3 squared, if we take the derivative of that, well, by the chain rule, you would want to move the 2 down. X minus 3 to the 2 minus 1 power, which is just 1. And then we have to multiply by the derivative of the inside. But the derivative of x minus 3 is just 1, right? I mean, you have x minus 3. That's a constant. It goes to 0. The x, you would just take whatever's in front of the x, but implicitly there's a 1. So actually, this is as simple as it is by the chain rule. Alternatively, you could expand x minus 3 squared as, well, if you FOIL it out, I think it should come to something like x squared minus 6x plus 9. Okay, so when you take the derivative of that, well, the 2 comes out, 2x. The negative 6x becomes minus 6, and the 9 just goes away. So 2x minus 6 is, of course, the same thing as 2 times x minus 3. So you could have figured it out either way you like. What about the y squared term? Well, remember that this is just like saying f of x squared. So if you take the derivative of this by the chain rule, you'd put the 2 out, replace it with a 1, but then you'd have to remember to multiply by, so there'd be a 2 there, and you'd have to remember to multiply by the derivative of the inside, f prime. Or, writing it in terms of y, we would have the derivative of y squared is just 2y, and then by the chain rule, multiply by the derivative of the inside is just y prime. Just like this. So a little bit of algebra. Move this over. And we have to subtract it, so that's minus. Or y prime is equal to negative 2x minus 3 all over, and we're just going to divide by 2y. And you'll notice these guys cancel, and this is just negative x minus 3 over y, and if you like, you can distribute the minus sign, and that becomes 3 minus x. It just switches the sign of the x and the 3 over y. That handles the first part of the problem. Now we're asked about tangent lines, and let's be clear about exactly what y prime tells us. This means that at the point a comma b on the graph of the circle, I'll just say on the circle, if you draw the tangent line to the circle at that point a comma b, right? So I'll just leave that implicit without writing it. At the point a comma b on the circle, if you draw the tangent line, it will have slope (3) minus whatever the x coordinate is, and I called that a, divided by, well, whatever the y coordinate is, and I called that b. 3 minus a over b. Right? So let me just quickly draw here. Let's say we pick the point x equals 3, y equals, well, 1 or negative 1, right? We have two options. But let's just say the point 3, 1, which is the top point of the circle. If we draw the tangent line here, you can obviously tell just for geometric reasons it should be horizontal, so we would expect the slope to be 0. And indeed, if we plug in this a and this b into this formula, or this formula, 3 minus 3 divided by 1 is indeed 0 over 1. It's 0. So for those of you who thought these were the 2 points, then clearly you're wrong. Those tangent lines are horizontal. So that's not what we're looking for. What we're looking for, let me switch to blue, is a line that passes through the origin and that's exactly tangent to this circle. It's not going to run through the top and bottom of it. it's going to be, that's not a very good drawing. It's going to be just ever so slightly to the left of these things, and it's also going to show up down here. So that's kind of what the picture should look like, and we're very clear, this does not pass through the north and south pole of that circle, the top and bottom points, because those, if you drew the tangent lines, would be horizontal, obviously, right? So just common sense says that that's the wrong answer. Alright, so how do we figure out the right answer? Well, notice that whatever these lines are, we know what their slope is. If I call this point, for example, this point where it touches the circle, a comma b, that's what I've been calling these things, okay, then the slope of this line is, on the one hand, well, it passes through the origin, so, sorry, it doesn't go all the way to 3, it stops here, right? So the change in y is obviously b, and the change in x is a. Well, that's the x and y coordinate. So the slope of this line, on the one hand, just the fact that it passes through the origin, and the point a comma b, the slope of the line is b over a. But if it's going to be tangent to the circle, then the slope must also be 3 minus the x coordinate divided by the y coordinate. 3 minus a divided by b. Okay, well, what does this tell us? If b over a is the same as 3 minus a over b, well, multiply both sides just by b squared, and by a you get 3 minus a times a equals b squared, right? So, in other words, if this line is going to, on the one hand, I mean, just the fact that it passes through the origin means that its slope is this, because it's a line that passes through the origin and this point, and you can just look at the change in y over the change in x. But if it has any chance of being tangent to the circle, its slope had also better be given by this formula. And that's what we figured out here, right? At the point a comma b on the circle, if you draw the tangent line, it will have slope 3 minus a comma b. We're at the point a comma b on the circle, and therefore, if it's going to be tangent to the circle, it should have that slope. So that must mean we expect to be able to solve this equation, b squared equals 3 minus a times a. But we also know a squared plus b squared, sorry, not a squared plus b squared, my apologies, a minus 3 squared plus b squared equals 1. Why do we know that? Because a comma b is a point on the circle, and that's the equation that all points on the circle satisfy. So we have these two interesting equations. From this second equation, we just move this term over. B squared is 1 minus a minus 3 quantity squared. So on the one hand, the condition of these slopes matching up perfectly means b squared had better equal 3 minus a times a. But just from the fact that a comma b is on the circle, b squared had also better equal 1 minus a minus 3 squared. So if we set these two things equal, b squared equals both of these things, so 3 minus a times a is equal to 1 minus a minus 3 squared. Okay, let's actually FOIL these things out and expand them. 3a minus a squared equals 1. And let's see, I hope I don't make a mistake here. I'm FOILing and I'm distributing this minus 1 right here. That should be a squared. That would ordinarily be negative 6a, but there's a minus sign, so that's plus 6a. And then that would be a plus 9, but we're subtracting, so that's minus 9. Okay. Or moving everything over to the right-hand side, what will happen is the a squareds will cancel when we add a squared to both sides. This 3a we get subtracted from the right-hand side. You're going to have 6a minus 3a comes out to 3a. And then we have a 1 minus 9 is negative 8. Right, so now we can solve for a, and a should come out to, adding 8 and dividing by 3, a should equal 8 thirds. So what is 8 thirds? Well, this is, so if we're writing it like elementary school students, that's 2 2/3, right? So it's just shy of 3. And that's exactly what we expected. We expected this point, just kind of look at its x-coordinate, it's not quite 3. And that's 8 over 3. That's just shy of an x-coordinate of 3. So we know that then this would be the x coordinate. So let's just be very clear about what this thing is. Okay. So this would have to be the x coordinate of the point on the circle whose tangent line, right, tangent to the circle at that point, passes through the origin. You can also easily, from this equation and from going back to any of these other equations, the one that came from the slope or the one that came from the circle itself, you can figure out what the b coordinate would have to be too. So for example, the second equation, b squared would have to equal 1 minus 8/3 minus 3 squared. Well, that's negative 1/3 squared, right? So 1 minus negative 1/3 squared, which is equal to 1 minus 1/9, which is, I believe, 8/9. Does that check out? Yeah, 1/3 squared, the minus signs cancel, that's 1/9. So I think that checks out. Alright, so b squared would have to equal 8/9. So b would equal, and there's two b values, which we expected, right? Because there are 2 points on the circle that would have tangent lines that pass through the origin, right? Right about there and there. The x coordinates are the same. It's the same x coordinate, 8/3. But the y coordinates should be negative of each other. So there should give a plus or minus, and on top we have radical 8, and on the bottom we have radical 9. So I'm just taking the square root of both sides of this equation. And radical 9 is just 3, right? So there you go, plus or minus radical 8/3 is your b coordinate. And these are your, this is your x coordinate, these are your 2 potential y coordinates. So let's be very clear. The points in question are 8/3, comma, radical 8/3, and 8/3, comma, negative radical 8/3. These are 2 points on the circle, and if you draw the lines tangent to the circle passing through those 2 points, it will also pass through the origin. Now, if you're actually asked for the equation of those lines, well, notice that, you know, the equation of a line is always y equals mx plus b, right? And this is always the y-intercept. It's where it strikes the y-axis. Well, we know that it strikes the y-axis at the origin, so there's not going to be a y-intercept. The y-intercept is going to be 0. So equations are always going to be of the form y equals mx, where m is the slope. And what is the slope? It's just, like we said, it's b over a. It's the change in y over the change in x. So b over a, right, the slope of this line is radical 8/3 divided by 8/3. And the slope of this line is radical 8/3 minus radical 8/3 divided by 8/3. And I guess the thirds are going to cancel. It's going to be radical 8/8 or 1 over radical 8, I think. Make sure I didn't make a silly algebra mistake. These guys cancel. This radical 8 cancels with one of that, and it becomes negative 1 over radical 8. So it seems that so these would be the slopes then of the 2 lines passing through this origin. And like I said, that's all we need to know. Because y equals mx, there's no y-intercept b. So the 2 lines are 1 over radical 8 times x and negative 1 over radical 8 times x. Just like that.